Hello everybody and welcome to today's webinar. I'm joined this afternoon by Gil Zilberfeld, who will be talking to us today about TDD for the rest of us. Gil is a frequent speaker at international conferences on the topic of unit testing, TDD, agile practices and product management, and he's also the author of Everyday Unit Testing. So we're delighted that Gil has agreed to come along today to present for you guys. If you have any questions for Gil during the course of the webinar, please feel free to type them into the questions field there on the control panel, and Gil will look to answer these questions as they come in. If you can't get to the questions there and then, we'll look at them a little later on in the presentation. So let's hand over to today's presenter, Gil.
Okay, hi everyone. I'm Gil. Thanks for introducing me. And I'm going to start this session the way this session started. It was like something like 5 years ago. And I was going to do a workshop about TDD, test-driven development, which I'm going to explain in a few minutes. But this was in a testing conference. And usually TDD is something that's connected to developers. So I was waiting in everything was set up at the workshop, and I was expecting people to come in, and people came in, but they didn't come in with laptops. Some of them came with tablets. And I was thinking, these are not regular developers, are they? And I asked them, what are they doing here? And they said that we're testers. And we heard about TDD. We wanted to know what it is, what it means for the testing world, what it means to anybody else. So everything I prepared for that workshop was thrown out the window that minute. And what you're going to see today, what we're going to do today, is basically what came out from the session that we actually created on the spot there. And the idea is that test-driven development is not just for developers. And we'll see what we mean by that. So that's me. I have a couple of sites. One is the book, the Everyday Unit Testing, that they mentioned. The other one is my site, zilberfeld.com, where you can find all kind of agile stuff, all kind of stuff. And if you want to get in touch with me, I live on Twitter more or less, so you can find me there. Right, so let's begin. So TDD is usually it's called, the acronym stands for test-driven development. Some people call it test-driven design. And what do we mean by that? So we're actually writing the test before the code. So everybody who picked up some kind of research or did a query on the internet about TDD would probably see something like this cycle. And this cycle basically starts out with us writing a test before writing the code. Now this, when you explain this to developers, they kind of get this scary look on their face. And they can't really understand how they can test something before they actually written the code for it, which is kind of understandable. This is how we taught developers to write code. You write code, somebody else will test it. And that's a bit different. Not only are they someone who are going to test the code, but they're actually going to test something that is not really there, which is kind of new for most people. Once we've done this, we have a test that doesn't work, doesn't fail, it fails, and it could fail from different reasons. It could fail because something is not compiling, the code itself is not compiling, or the functionality is not there because we haven't written it yet. So once we have that, we have one single test that if it's failing, we'll move on to write just the code to make this thing work. Now this is very important. Mostly when we write the code, we do all kinds of things together. We first need to make sure that it actually does what we want. Second thing is that we actually want to make it readable for other people as well. And we kind of mix that together, and if we mix that together with trying to write all the kinds of functionality that we think needs to fit there, because we're trying to answer all the design questions, all the things that the solution needs, we kind of jumble it up together. With TDD, it's not like that. We are trying to answer one test at a time. And even then, we first try to write a functionality for that test specifically. And we separate making the thing work, that's the green part, and making the things readable, understandable, without code redundancy. That's the refactoring part. So we actually do the separation, and we actually do it in the code itself. First, we make sure things are working, then we're actually refactoring. And refactoring is not just for the code itself, not just the production code. Refactoring is also for the tests that we're doing. And this cycle goes on and on and on. And it's kind of a weird thing to do. Because when you start doing it, first of all, usually it's not something that you can do a tester read developer. Well, you might, but usually the person who writes the test is the person who will actually write the code. Unless you're doing some kind of pair programming, and then you can switch. But usually it's kind of a one person doing two jobs at a time. Like person thinks on different ways to do things at a time. And like I said, this is very weird way for developers to work. However, if you think about it, that's a very good way to think about how to write code, because the red part says this is how the code, this is what the code should do. It doesn't specify how the code does it, but basically we're coding a requirement, a specification. And we're doing it one requirement at a time, a very small step at a time. And if you think about it, this is a way to write incremental software. So in the grand scheme of things, it actually makes sense. Not for developers, but for the rest of us, yes. So let's see. Well, the only way I can present TDD that people understand is with Star Wars. So what we're going to do is build a lightsaber. So you see on the screen different lightsabers and different persons from Star Wars. What I'll do, and what we'll do, is I'm going to switch to Visual Studio. Now I'm going to do this in C#, but what we're going to do here is basically something that you can do in any language, because the methodology is really out there. All you need is a test framework. Every kind of language has one, and you can play with it, whatever language and ID you want. I've decided to do Visual Studio in C# because that's my go-to thing, but you can pick any language and ID. So what we do first is understand the requirements. So what do we need from a lightsaber? So usually I do this as an interactive part, so actually drawing people to talk about. But let's see what we have here. So the first thing that comes up is that we probably have an on-off capability, okay? And usually I'm asking, well, if we have like an on-off, what are the, I'm looking for verbs. What does the lightsaber do? Because verbs means this is going to be the interface. So on-off is not really an verb. So turn on, turn off is. Usually what comes up after that is that the developer says, well, what do we need to turn on and turn off? Let's give it a method called getStatus, which is great for developers because nobody other than developers says getStatus. Especially not Jedi warriors. I'm not sure if you've met some, but they don't speak in terms of getStatus. Usually people don't do that. It's like it's a software thing. TDD originally started out from Kent Beck, actually way before that, but it was part of the extreme programming movement where testers and developers actually talk to customers, and the code was written in the language of the customers. Even if, again, if you think about it, it makes complete sense. Why should we have different languages? Like the customer speaking in a business language, the developers in their developer language, and the testers in the test language. It doesn't make sense. We want the same language in all through these layers. So when TDD started, it was kind of a bridge between developers and the customers or the users, because tests were written in the language of the users. So get status is not something that user will say. Think about it. What else do we have? We have that, you know, when it's actually cutting things, right? So people say, well, we can slash, but that's what the user does. That's not what the lightsaber does. So when we're writing this test, and we haven't written a word yet, right? We started to think of what does a lightsaber do, but how does somebody use it as well? And if the user uses it, what does it mean for him, and what kind of language does it need to that the user needs to reflect? What is the object that we're trying to build? And obviously it does sounds. It might have like features like belt clip or color. Okay, so it might have something like called color. So all kind of things. And while we're trying to write this, we're trying to write not just features, we're trying to think about test cases. So for examples, I'm going to concentrate today on power on and off. So let's write these things. Test cases. If we turn on off, from while the lightsaber is off, we expect it to be turned on. If we can, obviously we can turn off while it's on. We want it off. And we can start thinking about other cases like turn on while on. What happens then? And this is a way that we start thinking about requirements and what does it mean turning it on, what is it on? So maybe it has a toggle switch. If it has toggle switch, that means that turn on and turn off does not really translate to what the lightsaber, how the lightsaber works. But if it has the semantics of turning on and off, then probably after turning on, nothing will happen. So, and we'll need to discover what this means. Here's another example of digging into requirements before writing any piece of code. So if you recall our heroes here, so you see Luke Skywalker at the bottom has a blue lightsaber, and Darth Vader has a red one, and Yoda has a green one. And Mace Windu, who's Samuel L. Jackson, must have something very special. Here's the purple one. So here's the question. If Luke Skywalker drops his lightsaber and Yoda picks it up, is it still blue? This is a very interesting question. The answer is yes, it is blue. But this is how we think about requirements. And think about it. We're talking about describing a feature in the lightsaber, its color. And we see that sometimes the color depends on something else, originally of who built the lightsaber. But it could be that in some instances, it doesn't have to be. Like we could, if we wrote Star Wars Chapter 9 and we'll be very rich, we could decide that whoever picks up the sword decides on the color. So this is how we think about requirements, and that's just thinking up front. And testers, you know this. You know how to think about requirements. Sometimes they are not enough. Sometimes they don't tell their whole story. But we need to dig in. And that's what we expect developers to do as well when they're writing their tests. So, going to switch back to Visual Studio, and what we'll do is, you see, this is the test files and this is the code file. And what I'm going to do, like you see, I don't have anything in under my sleeve, no code at all. So what I am going to do is going to start to write the first test. So in C#, it's called the test method. And what am I testing? So when I'm giving the test a name, I'm trying to give it an English name, or at least something that's readable and understandable in the language that I use with my users and so on. So that would be something like I've written before. So when light saber is off and turned on, it turns on. Something like this. Now, currently I have an empty test. If I compile it, I'm using keyboard shortcuts, what you'll see on the result is here. What you see here is what you see on the CI, on the continuous integration tool later. So test names are very important. And they're very easy. It's much easier to write this up front where everything compiles and we don't have any squiggly lines that tells something is wrong because we haven't written any piece of code. It just tells us that what we're going to focus on. And this is one of the magic of TDD, is that it lets us focus on the current tests. So how does it look like, this test? I'm going to close this a bit. So let's see, I'm going to need a lightsaber. And you see the squiggly lines appears because I don't have a lightsaber class yet. So I have a saber and I just created it. And you know what I was thinking? Maybe that's not the first test I want to do. What I'll do first, maybe, is this. I want to test when a light saber is created, it is off. Now what you've seen right now is something that happens to developers all the time. They might not tell you that, but we're not thinking very linearly. We're jumping from place to place. You probably have experienced that yourself. Humans do not think linearly. So when we're thinking of one thing, something else might pop up. So what we'll do is, I'm going to comment the other thing is the first test. I'm going to comment it out. Hold on. Yeah, green is better. And now I'm going to write the first one, because remember, we're focusing on one test at a time. And what we'll need to do is create this lightsaber. And now, how do we check it is off? Remember, we don't have a lightsaber class yet, so that's why everything's squiggly. So I can decide whatever I want. So I'm going to say like this. I'm going to decide that I'm going to check that saber, and I'll give it a name called is off, is true. Okay, so what will happen, basically this doesn't compile obviously because it has all kinds of squiggly lines. Compiler tells so compiler says, let's first create a class. So lightsaber, and see, well, this should, yeah, okay. So let's compile and see if it already compiles. It doesn't compile the isOff method, so we need to add that. So isOff is something that I decided to check is true on. That means it's a Boolean. So I'm going to add a method called isOff. And I'm going to return false. Because, return true. Because that's the quickest way to make this thing pass. Let's see if it does. First of all, it compiles. I'm going to run it. And it's green. Excellent. Now let's see what we've done with just one test. First of all, we jumped from one test to another. On the way to the first test, we discovered it might be easier to start off with something more simple. And that is, we moved to another test we created. Second thing is that obviously I decided that there's going to be a class called lightsaber, and I named it lightsaber, and I named it with a capital L with a capital S, and that's my choice of design. Also, I decided that there's a method called isOff, and I decided that this is the way to check that it's off, which again makes sense, right? This is how I wrote the name of the test. This is what I'm expecting to do. So, sorry. So we have one test running. Let's see if we can refactor. Remember, refactoring is something when we change something either in the code or in the test and make the code better. So basically, I don't see anything wrong with the test so far. Let's see at the code if we want to do something that, it's pretty much okay. Pretty much say kind of self-explaining what it does. So let's move on to the next one. Luckily, we have this from before. So let's see. So in our test, the second test now, when the lightsaber is off and it's turned on, it is turned on. So let's see what we have. So obviously we're going to create a lightsaber again. We're going to need to turn it on. So let's have the method called turn on, because this is how other code will use this code, right? We're trying to think about how somebody will use the lightsaber. And currently we're actually defining how other parts of production code, not just the test, because the test just comes here first, but how other production code will use our lightsaber. So if you're thinking about wrapping our lightsaber with APIs, this is how the inside will look like. Okay, so what else? And let's see. Okay, so now I'm in kind of in a dilemma. I can write this saber is off. So that's one option. Is off is no longer false. But does that mean it is turned on? Because the other way I can do this, I'll comment this line and write it again, is it is more likely that I will ask, is saber on? And this is already a design issue. That's a problem that I need to actually think, see if it's going. I'm going to scroll a bit. So what you see right here is really making me decide before I even write the code how somebody's going to use it. Now, why is that important? It is important because when developers write just the code without the test and they're not thinking how somebody will use that code, they kind of create something from the inside but not for somebody else. and they're kind of creating all this, like we said, all the requirements or the solution for the requirements together. We don't think about sequence of operations. So it's very important to just imagine how somebody will use our code. Like we said, it's important to use the same language, and it's important to be coherent. We'll talk about coherence in a minute. And we just want to answer one question at a time. So what I'm going to do here is I'm going to decide. So first of all, I'm going to use turn on as the method. That's okay. This is how you turn on a Sabre. But I'm going to decide, again, my decision because I write the code, that for English sake or readability sake, I'm going to try to have Sabre is on. Okay? Obviously this doesn't compile. I have red squiggly lines. So I'm going to jump to the code. And write just the code that makes things work. Let's see if that works. So it does. That's correct. It also has a turn on method. Sorry. Yeah. Now, first let's compile. It needs a void method. Yeah. First let's compile it. Now let's run all of them because I might not have said that, but you run all the tests all the time. Okay. Still running. Is it still running? Yeah. And everything's passed. This is the point where you ask, really? What's happening here? I have two tests running. Is off always return true? Is on always return true? That's not how the lightsaber behaves. And that's true. That's one of the problems that developers have with kind of grasping the step-by-step nature. Okay? Because basically, this is obviously is off and is on cannot return true all the time. But the reason is that I haven't written a test that proves that they don't need it. The cool thing about TDD is, first of all, I can cut off at any point. Like if somebody told me, you have to ship now, whatever you have right now, I know that this is working. Whatever I wrote until now is working. The fact that I haven't written all the requirements, everything just to fit all the other requirements that will come later, that I can think about, and those that I can't think about, something that is hard to grasp. And it's okay because this is a process. This is a part of the incremental process. And some people have a tough time just putting, let's call it, stupid code in, because obviously return true is not going to be there for every time. But it is for our case now. So what we're going to do first is refactor, right? So let's see at the code. Let's look first at the code here. So the lightsaber itself looks okay. Turn on doesn't do anything. Is on always returning true. Not much I can do about it. What I can do is that I see that I have this kind of duplication here. So I can just create the lightsaber as part of the class. And look, I've done just one change. I'm going to do another one soon, but I've done a few minor changes, but it's okay because I'm going to run everything just to make sure that everything still runs. And everything is still running. Hopefully, come on, run all, run all, run all. Yeah, everything's still running. And Now I can do like add a setup method. Setup method in C#, it's called test initialize, something that runs before every test. Let's call it setup, just to confuse the initialize thing. And here I'm going to copy this and remove this. So the setup method runs before every test. So before every test, I'm just going to create a new lightsaber. And the setup method is like a place for common initialization. I've done this. Let's compile and see compiling yes. See that everything's still running. And everything is still running. If something broke, I can do a couple of undos and get back to a working state. This is something that you don't have when you're just writing the code and patch the test later. This is possible to do with TDD. Okay, so let's see what I have now. I have two tests. One is them checking the off, one of them turning the on. So obviously I want to see how is on behaving after at the starting off the lightsaber. So when lightsaber is created, it is not on. So I'm going to add a test that says that is on is false. Let's compile. And this time it compiles because we didn't add any new method. It's going to see if everything runs. And of course, it fails because I've added now expecting a functionality that's not there. So let's see what we can do about this. So let's define a private Boolean called is on. Okay, and what we'll do is this. In is on will return the is on member. And it is off will return the opposite of is on. At least that makes sense to me. Let's see, just because kind of confused, we'll call it is on with a small o. Less confused now. Let's build it. And let's see if everything still works. Everything still doesn't work. Excellent. Because we haven't done anything. So on the turn on, we need to make is on small to be true, which makes sense, right? Let's compile it. It's completed. Let's see if run all works. Yeah, everything works. So what have I done? I now added a very small part of functionality that makes everything until now work better and improve that. Now I can say, well, do I really need an is on and an is off, and sort of decide on the design that I actually want. But what I've done until now, which seems like a very long process for a couple of methods, is define how the behavior of the lightsaber will work from the outside. Now you might say, okay, this is just for one method or three methods, all this process. The thing is that imagine when you're working on a whole system, an actual system, not just a lightsaber, which is very complex. And you need to hold all the details in your head. And you have to write all these details down in code and make sure that they're still working. Now, I'm not saying it's not possible. You can do that without tests. But it is going to be a long iterative cycle because as a developer, when I write these things, I think I have all the models in my head. I write it down the code. It might not be the same model what I've written. And then when somebody tests it in the whole system sort of thing, they'll discover things that I haven't thought about. And then when that happens, like 3 months later, after I've written the code, going back to this cycle is very hard. So obviously the test helped me there. But the magic here is that it makes me think about how I am going to cut down the big problem into very small step, very small slices. And by that, I can focus on that, solving the small problems step by step. And I can build very big systems, and I have, using this method. That's TDD in a nutshell. I'm going to, you can start writing questions on the Q&A because I see people starting out. I'm going to, I have two or three more slides I want to cover because I think it's important to talk about those. So yeah, you can see sometimes lightsabers are not what they seem, but we're not going to talk about them today. Let's talk about benefits and issues in TDD. And first of all, if the developers are using some kind of unit testing tools and CI, like Jenkins and so on, Microsoft TFS, they're using the same tools. You don't need to introduce new stuff. The TDD tools are the unit testing tools. For everyone's a coverage junkie, you get better coverage, and that makes sense because you write the test before the code. So obviously the test is going to be covering the code. So you get better percentage of code coverage. The whole thing of code coverage, I can spend an hour talking about how I dislike it, but not today. One thing that you discover when you work step by step like that is that you're debugging a lot less. And the reason that you're debugging a lot less is that everything worked up to a few seconds or minutes ago. And that's important because if everything worked up to a few seconds ago and you messed things up, that means that, yes, you can debug and find out what the problem is, but other than that, just throw a couple of undos or control Zs or whatever and go back to working state. And you know that everything was working when every test was running and everything was green. You'll spend a lot less time debugging this way. And debugging is a very big bucket of waste that developers seem to like wallowing in, but it is a major time waster. So you'll find out that you're debugging less. So this is one of the selling points that I use in order to convince developers to do that, but we'll get to that in a minute. Now, every time you read about TDD, you'll find out that when you're using TDD, you get to a better design. And I put a small asterisk in. It could be a very big philosophical question, what is a better design and what it used to be. Usually testable design, and this is what we're building, obviously, because we're able to test it, has a lot in common with good design. If you look at object-oriented languages, we talk about solid principles, it has a lot of commonality with it. However, if you're a crappy designer, you will have crappy design, regardless if you use TDD or not. By the way, you'll have some crappy tests as well, but the design by itself is not really governed by the tests. It's really governed by you, the person who writes them. If you're doing it together as pairs, there's a bigger mind involved, you probably do a much better job than one person. But it is up to the experience of the developers and the testers. We talked a lot about language used in the code. So if the developer decides to use another language, the design might not be that visible right from the code. One of the biggest thing about TDD is the breaks that it puts inside your brain. Instead of me just rushing in to write any code that I like, that I think is the right code to write, it just puts the brakes in, and I need to write a test first, and then just focus on that test. And that's one which I jump to the other column of the issues. It takes a lot of discipline. It takes a lot of discipline to do it because most developers are not taught to write this way. And we're thinking, even the greatest waterfall thing, we're thinking of a good design to solve the entire problem, and then we start coding it. We're not used to doing this kind of small cycles, sometimes writing stupid code, because nobody taught us to do that. So to keep doing that, we need discipline. That's hard. It's easier to do this in a team, when the whole team decides, okay, we're going to adapt that. Usually one person at a team doing TDD and the rest not even writing tests, it's going to be a disaster. What else can I tell you? What I showed you is for non-existing code. It's very hard, very easy to write tests for non-existing code because nothing stops you there. But in real problems, real systems, we have components that we've written before, and we have architecture that is already set there, and maybe we're calling third-party APIs that's not ours. So it's harder to do that then. Which is to say, basically, oops, Yoda jumped it. Which is to say that if you have all kinds of constraints in your project, it's a constraint that you'll need to work around. It's kind of antithesis to the design that we put in. I can't just call it isOn if it doesn't have an isOn method on it. But if you find the boundaries of where you can play with the design, things become much easier. It's easier to do when in big greenfield projects where code is not written, or greenfield components, or even parts of the code that you're now adding, and you can find and draw the boundaries of where you can actually play with the design. The final things and that's the problem also with unit tests or any change that you introduce in the development process, it takes time to get a great result. When I started out working in a company that most of my code was written in TDD, most of the code in the team was written in TDD. This was the first time I actually written production code in TDD. After 2 or 3 weeks, I knew that I was great in TDD. A month later, it came back to the point where I don't know anything about TDD. And in a year and a half after that, I realized I'm okay with it. So it takes a very long time to understand what's TDD like, because it's not just a way to write code. It's a way to understand, describe. It's a whole set of skills. What kind of steps do you take? The thing that we did when going back to a more simpler test is something that comes with experience. Refactoring everything, including tests. Again, skills that you need to master. And the developers need to learn all this. So getting good in it takes time. So what does Yoda say about TDD? First of all, what you might read about TDD is that it's just one step at a time, and that's not true. It is true once you start writing code, but you need to do some kind of planning test cases, what you're going to test and so on. If you're working in an agile team with testers and developers work together. Decide what things are going to be done at the unit test level and what are going to be done at other levels. And testers are much better coming up with test cases than developers. That's the skills that testers have. So they can help with A, telling what kind of test cases we need. B, what kind of, how are we going to test that? How do we know that it's working? Help developers. Define the boundaries of where you're actually going to do TDD. Sounds simple, but in real systems that code already exists, it's not that simple. The discipline of having very small steps is very important. Smallest amount of code to pass the test. Again, that's part of the discipline, and you need to do that. It's very easy to jump, yeah, but I'll need that for the next test case and so on. Part of the script, part of our process is just writing just the amount to pass the test and not just to pass the test. It's very easy, but also hard to try to focus on the current test. Having just one test failing helps us focus on just fixing that thing. Obviously, if I'm fixing just one test and 5 others fail, I'm not done yet. But it's one small problem outside a very big model in the real world that we need to fix. And that's easier to think about that. One of the things that you'll find as you're working through this process is that you have questions. And as testers, you know that. Specs aren't complete and you find things on the way, and you need to ask questions. This is not just one developer going to the computer and thinking up whatever it needs and whatever assumptions that they think that this is how it should work. It kind of helps us present more questions to the business analyst, the product owner, and other developers and testers, and just ask questions. And like I said, if I haven't mentioned it, it's about discipline, discipline, discipline. Okay, and we're not going to do that. Yeah, we need to remember this. So that's my presentation for today. Please write more question in as in the box, and I will turn them to a moment. There, back to you.
Thank you very much, Gil, for that presentation. And as Gil mentioned as well, we're going to look at your questions very shortly. So if you haven't typed your questions, please do so now. We have another webinar taking place this week. That's with Michael Bolton, and he's going to be looking at test cases. So to register for that, head over to the Huddle website and look at the upcoming webinars slide. And you'll also find these webinars here that are coming up over the coming months that look at agile leadership, maintaining quality with agility, Java memory, and we'll be continuously adding more and more webinars to this site, so make sure you check that out over on Huddle. Now this is a big week for us here at EuroSTAR because tomorrow we are going to be announcing our program for the EuroSTAR Conference 2017, which is taking place in Copenhagen from the 6th to the 9th of November. And from now up until midnight tomorrow night, you can avail of a 20% discount on all ticket prices. So to check this out, head over to the EuroSTAR site, and the link is there, pre-launch discount 2017. We have another conference that is taking place as well next month, a brand new conference called EuroSTAR. It's a one-day testing event which will be taking place in Oslo on May 11th. And the information about this conference is found on eurostarsoftwaretesting.com/EuroSTAR. So that's it from me, and I'm going to hand you back again to Gil. He's going to go through your questions.
Okay, so the first question is, how do I sell TDD to the devs that don't like it? And I'm not going to spend an hour on that. The first thing is that you need to understand you can't sell any process. Okay, you wrote that the devs don't like it. I'm not sure if they've heard about TDD, tried TDD, what kind of level of unit testing experience they have. But TDD is like any other process. It's like code reviews. It's like code documentation, anything that you decide as an organization that is important for the quality of your code. Now, if you decide that this is important, some people won't like it. Some people don't like code reviews. A lot of people don't like code reviews. But if it's important, people understand that it is important for doing the quality, for maintaining quality and getting to higher quality, that would be the first thing that I would work on. I usually tell them that, tell developers that writing tests, not just TDD, writing tests is part of the job. This is what makes you professional. If you don't write tests, you're not as professional as you think you are. So it starts with that. It's understanding what you're trying to sell here, and don't like the word sell. So if the organization decides that this is how it's going to work, this is how it's going to work. And this is a good way to work. The problem with the TDD, the problem with unit testing, the problem with code reviews, that like I said, people don't learn that that this is the right way to do things, if there is a right way. So what you're coming, the position you're coming from is trying to convince them that this new stuff that you heard about in a webinar is much better than the way they do things right now. And nobody likes to hear that, not developers, not testers, not anybody, even product people. So it doesn't work like that. The way to install new processes is usually through experimentation. Let's try this. I usually ask in my lectures, who's done pair programming before? And most developers don't raise their hands. And I tell them, well, every one of you did, because at some point you had a bug and you didn't know what the answer was, and you called someone to look at your code and said, okay, let's see what's happening here together. So like pair programming, it's something that you have to try. It is not easy to do, like I said. It's not easy to see the immediate value. That's for testing as well. But if you decide that this is important and you're taking an experiment, it is going to be a while. Some people won't like it. Some people don't like to read documents. Some people don't like to write documents. I understand that, but that's part of the professionalism that you decide that is good enough for your quality. And if people don't like that, there's not much that you can do, basically. But you can encourage them to try it. And hopefully some of it will stick. If you have more questions, write them down now. Otherwise, we'll just finish and complete this.
Okay, we'll give you another moment just to get your last questions in there. And in the meantime, I just want to mention as well that this webinar is being recorded, and a copy of a link to the resource page where you can view the webinar recording as well as the slides will be sent out to you all in roughly about an hour's time. Okay, I don't seem to see any more questions there, Gil, so I think we might just wrap it up at that. And just want to say thank you very much to our presenter today, Gil, for taking the time out to talk to us today about TDD, and thank you to all of our attendees. We hope to see you at future webinars, and make sure you stay tuned as well for our program launch taking place tomorrow. So head over to the EuroSTAR conference website for that. So take care, everyone. Have a good day.
Thank you very much.